In this video, I'm going to give you a brief overview of the proc-reg function from the procs package. This is a function that can perform a linear regression, and it's similar to the proc-reg function in SAS. So the first thing I'll do is load up the procs library and create some sample data that we can use in the rest of this video. And then we'll do a very simple model, weight by height, and see what that does. And as you can see in the viewer here, I have this display come up with a few tables with various statistics in them. And if you were to compare this output to SAS, you would see that it's nearly identical. The only thing really missing is the plots, which will come in a future version of this package. And the model syntax I used here is resembling the SAS syntax. The only real difference is that I have to quote this to use the SAS syntax, because if we were to do model equals weight equals height, R would get really confused by that. So if you want to use the SAS syntax, just remember to quote that model. By using R syntax, then we use the tilde to separate the dependent and independent variables, and that identifies this thing as a formula, and then I don't need to quote it, and the output is exactly identical whether you use the R model syntax or the SAS model syntax. You get the same thing. So this is really a preference item, and if you want to pass multiple models using the SAS syntax, you just put those model statements in a vector of strings, and then when we look at the output, you'll see I have model 1 and the results from that, and then model 2 and the results from that. And similarly, if I were to want to pass multiple model statements using the R syntax, I just pass that as a list. And we have to do a list here because these statements here are actually formulas and they're objects, and we can't create vectors of objects. If we have a collection of objects, we need to pass those as a list. So if you want to use the R syntax with multiple model statements, you pass those as a list, and then you get the same output. So that's very nice. Now you may have noticed as I'm doing this that I'm getting stuff up in the console here, and what that is a data set that's being returned by the function, and in this case it has nowhere to go, so it's going to the console. So in this next example here, we'll look at the different kind of output you can create with this function. What I'll do here is run that exact same function we just saw a moment ago, but this time I'm going to save the result in this variable res, and then you could see that here. So this is useful if you want to do something with the results of this function. And you'll notice that the output, what has been output as the data set from this function, the return data set, is quite different from the interactive report. And this is very common in SAS. The interactive report usually has a lot more stuff, and it's organized differently, and it might have several different tables and charts and things. And this is really for kind of exploratory interactive display, whereas the data frame or the data returned is for programmatic use. And so typically I wouldn't need all this stuff if I just wanted to get my coefficients out. And so SAS organizes these two things differently. But there are many options if you want to get more of these statistics into the data set. And this first one we'll look here is called out-SEB. And to apply this option, all I do is set that on the options parameter here. So same model with the out-SEB option gives me a little bit different data set. It gives me the standard error rows here on the output, and you can see it's separated between model 1 and model 2. Another popular option is this table out. So this is the exact same setup with the table out option instead of the out SEB option. And what this gives me is the standard error again, but a lot of other things too, the t value and the p value and the confidence limits. Again, separated by model. And it's kind of nice that they're in one data set. It makes programmatic use easier. Another thing you can do with this function is pass by groups. This is a very convenient feature. Now I'm going to do the exact same analysis I did a moment ago, but this time I passed a by group. On the interactive report, I have now different pages. Those by groups have been separated into different pages. I can see my male and female results of the analysis. And since there's two models, I actually get the by groups for both of those models. So I get 4 pages of results here. And this is very typical of SAS. You can get a lot of stuff out of it with very little work. So you just pass a few more options and you get dumped with stuff in the display. And likewise, in the output data set, I now have a by variable that's separating the rows of the different by groups, and you have all the same coefficients that you had before. Now, if you wanted all this stuff in the interactive report, all these different statistics, it's quite convenient to have them all. What you can do in the procs package, and this goes not just for this function, but for all the statistical functions in the procs package, is pass this report option on the output parameter, and that will give you the exact data sets that were used to create the interactive report. And this is actually easier than it is in SAS. In SAS, you would use an ODS statement, and it's a little bit more work. This is incredibly simple. You just pass this option. And now instead of a single data set, I get a list of data sets. And they're named in such a way that you can know what they are, and you can access them quite easily with $ syntax. If I were to put that $ after my variable here, I have all those different tables that have been spit out by the function. And if I just pick one or type one, then I get only that one. So this is if you want to do some sort of further manipulation of that data. Now in SAS, there's even more options. What we've been looking at here are the options that are equivalent to the options statement in SAS, but there's also model options. And in SAS, this is typically specified after the model statement. You would put a slash here and then put some statistics keywords or option keywords. And in this function here, those model keywords are passed on this stats parameter. You can't do it the same way in SAS, so I have a different parameter here to pass those model options. And if we run this with the CLB stats option, I will get some slightly different results. In this case here, I'm going to get my confidence limits here in the parameter estimates. Now I had my confidence limits in the output data set from that table out option. And so this is how you can get the confidence limits either way. And you can see by default, they're coming up as 95% confidence limits. And if I wanted to have a 90% confidence limits instead, I would pass that on the alpha option here as 0.1. And that comes out as 90 on the display, and then also 90 on the return data. Here's another option for heteroscedasticity, and this will come out on the report here. And then if I want those same values in the data frame, I just pass this report option on the output. And so now I have all those statistics in my parameter estimates table if I want them. And here's one more model option, which is this P, stats equals P. And this will give me my predicted values in the interactive report. And this little summary down here. And then also in the return data set, since I passed that report output option, I get those predicted values in a data frame. Now, one thing you may have noticed, I kind of bounced over it, is this v function. You maybe have seen this before if you looked at any Sassy code, and you might be wondering, well, what is that? And there's another curiosity here, which is these options, almost all of them are passed unquoted into this procreg function. And this brings up this question of non-standard evaluations. And so we're going to take a little diversion here and talk about non-standard evaluation. This is a concept that's quite peculiar to R. It's not anything you have to worry about in SAS because everything is non-standard. But in R, it is a problem, and we can see that problem by looking at a very simple function here, about as simple as you can get. I'm going to create this little function, my func, and I'm going to pass a parameter, my parm, and all I'm going to do in this function is print that parameter. So let's load this function. And now you can see that if I were to pass a value to that parameter, my parm, and not quote it, what I'm going to get is an error. And the reason I get an error is because it sees this, and R will try to then look that up in your environment. It thinks it's a variable in your environment or an object in your environment and tries to resolve it. And so it can't find it. And so that is why you get an error, because it's this unresolved object. And what it's expecting you to do is, if you're trying to pass a string to a function, then you just pass it with quotes. That's the default functionality of R, and that's the way most R functions are expected to work. And in fact, that is the way that procreg does work. If you want to pass those options quoted, you can. And in fact, that's what it's expecting by default. So here's an option called no print. What it's going to tell procreg to do is to not print the interactive report. And there it is. It didn't print it. It just gave me the return data set. And that's useful sometimes if that's all you want. You don't want to send things to the viewer if you don't have to. But here I can pass that same option unquoted. And if I were to do that, I'd get the exact same result. So how is that happening? Well, that's because the way procreg is written is, if it sees that the thing that you're trying to pass to it is not a string, it'll just convert it to a string. And then you don't have to worry about it. So you can pass it quoted or not quoted, and it'll deal with that as a single token. Now, what if you have multiple tokens or multiple keywords or multiple variables you're trying to pass into a parameter? Well, you can do that with the good old C function that everybody knows and loves. This just creates a vector of strings. We can also do it with this v function, and this is a function in the common package, which is a dependency of the procs package. It gets loaded by default, and all that will do is quote everything that's in parentheses on that function. So the v function is a quoting function. You send it in unquoted values, and it will quote them. That's it. So then what gets passed into the options parameter is quoted values, and that's why this will work the exact same way as this. There's no difference in terms of what's happening in the procreg, whether you use quoted values or unquoted values. That's nice because it gives you a lot of flexibility into how you use these functions. One of the problems with non-standard evaluation is, depending on how you use them, you can get errors, or you have to pass weird syntax to make things work the way you expect. But here in the procs package, we can kind of do anything you want, and you don't have to really worry about it. Here I'm going to pass my options, this little set of options, and put them in a variable first, and then pass it to the options parameter. And you can see I get the same results and don't get any errors. And I can go even farther and put my whole proc reg inside a function. And now this is kind of wild. I'm passing my data, my model, and some, not all of the options. I'm going to basically force this no print option onto the execution of the proc reg, load that function into memory, load all those parameter values into different variables, and pass all of that into my function, and I get the same result and didn't get any errors. So the net result of this non-standard evaluation discussion is that when you're using the procs package, you don't have to worry about non-standard evaluation. You pass things quoted or unquoted as your preference, and the functions will take care of things for you. And that concludes the overview of proc reg.